this experiment we will actually demonstrate Kirchhoff's voltage law. It is verification of Kirchhoff's voltage law. So what does this Kirchhoff's voltage law? Kirchhoff's voltage law says that for a particular loop, total voltage is 0. So summation of this delta V is equals to 0. That means if I take this Kirchhoff's voltage law, it is V minus V1. V1 is here, potential drop across resistance R1, and V2 is the potential drop across resistance R2. So V minus V1 minus V2 is equals to 0. That, or in simply we can say that is V is equals to your V1 plus V2. Okay, so we will try to demonstrate this thing using this experiment. So I will I will do the same thing. Whatever the circuit diagram is, I will make the circuits. So look at these circuits. Okay, so this is actually your power supply. Power supply, that means your V. Okay, after that one resistance, this is your R1. Okay, this is your R1 and this is your R2. These are connected in series. Okay, and this negative port of this are connected with this. Okay, power supply, and we are trying to find out what is the potential difference across R1 and R2. And all of you know that when we want to find out the potential difference, so we have to connect voltmeter in parallel. So this is your V1, so voltmeter connected across parallel of this resistance. This is your actually resistance. Okay, this is actually resistance box. So whatever I have taken this keys outside, that means I have inserted 50 ohm here in this resistance. Okay, similar thing, I have also connected this resistance, this voltmeter, okay, across parallel of this resistance, and also I have in this key I have taken out. So this is your 50 ohm. I have given the resistance inside this circuit. Okay, so this circuit diagram, whatever circuit diagram is there, I have done the same thing using these components. Okay, so next thing we will try to find what is V1, what is V2, and what is V. So let's check. So let's say it is your let's fix for anything like yeah, let's say it is your V is your 2.01. Okay, V1 is this thing, that is your, it is almost 0.9. Okay, V1 is 0.9 and V2 is, it is also 0.9. That means it is your 2, it is your 0.9, that means 1.8. So your delta V is almost 0. Okay, so similar thing we have to do for other value of this V. So let's pick another value, that let's say it is your 3. Okay, let's say it is your 3. So again we have to note down what is your V1. V1 is almost 1.4, and your V2 is it is 1.49. okay, so it is 1.49. so similar thing I can make a table. So look at this thing, I have already done this experiment. So applied voltage, first thing is serial number, applied voltage is this thing, that is your whatever the potential we are applying, okay, using this power supply. Voltage across R1, that is V1, voltage across R2, that is V2, and we will calculate delta V. Delta V is this one, that is V minus V1 minus V2. Ideally it should be 0, but in experiment it will not be 0. Okay, so there may be different issues, so like your internal resistance of this power supply and other thing, that's why it will never be 0, but it will close to 0. So after doing several times this experiment for other voltages, applied voltages, I have note down all these things, that is voltage across R1, that is V1, V2, and I have calculated delta V. So if you can see this delta V is very minimum. Okay, so it is almost 0. So from this thing we can conclude that our Kirchhoff's voltage law is verified here. Okay, so you can see that this delta V is almost 0. So from this experiment we can say that we have verified Kirchhoff's voltage law using this circuit diagram and using this circuit component. Okay, so this is all about this your Kirchhoff's voltage law. In earlier experiment we have demonstrated Kirchhoff's current law. So these are actually this is your outcomes, and the aim is to verify Kirchhoff's law. So one is Kirchhoff's current law, another is Kirchhoff's voltage law. Okay, so that's all about your Kirchhoff's law.